We started 2.4, and I told you a couple times, and I'm going to reiterate it, that the operations are the same. Associative, commutative, distributive properties all are exactly the same. An I is just, when we do math, it is considered just like a variable would be. But is it a variable?
No.
No. It's not a variable, but everything with math is considered the same. Okay? Combining like terms, I can move things around. The multiplicative property of multiplication, the commutative property of multiplication and addition work. All those properties work. So I'm going to keep using them in every math that I do. It's not going to change. So I have 4 plus 3i times 2 minus 7i. I told you it's just the same as everything else, so what should I do with this?
Combine like terms.
I should foil. So I get 8. Let's see, I got a negative 28 and a positive 6, so that gives me, so a negative 22, I, and then a negative 21, I squared. But what is I squared? Negative 1, yes?
Yep.
So this is negative 21 times negative 1. Which makes it a what? Positive 21. So I have 21 and 8 is 29 minus 22i.
Nice.
So did I do that any differently than if it was an X there?
For sure.
Not at all.
What was the only thing that I did differently?
You put
The
an
negative 1.
Wait, where did the I go for the 22?
It didn't go anywhere. I took out.
Oh, okay.
Okay. The only thing we did is when we got I squared, what did we make it?
Negative 1.
Negative 1. If I got I cubed, what would I make it?
1.
What's I cubed?
I.
Negative I. If I got I to the 4th, what would I have made it? 1. The only powers we are going to have are 1. When we are done with the problem, the only power of I that you should have is the first power. Because the second power of I is negative 1. The fourth power of I is positive 1. So you should never have anything larger than I to the first power in your completed problem.
Wait. Don't go yet. Sorry. Okay, it's fine. Just go.
Okay, so I'm not going to do any more of those because you guys know how to distribute. I'm not, okay? What we're going to talk about is a conjugate today. A conjugate is where I have x minus y, x plus y. It's also known as the difference of squares because when I multiply that out, oops, it's a minus. What happens to the middle term?
It disappears.
It doesn't disappear.
Yeah.
It zeroes out, yeah?
It's gone. It's dead.
Okay.
Never seen again.
So it zeroes out. Well, if you just think back at the last problem I did, when I multiplied that out and I was left with an I, wasn't I? So I still had an imaginary number, didn't I? I don't want to have an imaginary number in denominators, just like I don't leave radicals in denominators, right? I don't leave imaginary numbers in denominators. I don't leave different things. So we need to use conjugates. So it's a conjugate with anything, like what's the conjugate to x squared minus 6? X squared plus 6. Okay? So I can look at anything, it's exactly the same, but the middle sign. Okay? What about negative y cubed plus 17?
Negative y cubed.
Minus 17.
Okay, what is the only sign that changed?
The
middle.
The middle. The first sign does not change. Just the middle. Because what happens when I FOIL, those middle two terms will zero out then. Okay? So those are conjugates. Conjugates happen in all kind of problems. Complex conjugates have complex numbers, but it's the same thing. So we have a plus bi and a minus bi. So if I FOIL that out, I have a squared minus abi plus abi minus bi squared. Oh, that's a b squared too, I guess. Okay, so these two what? They zero out, yes.
Yeah.
What's this I squared become?
1.
1. So you have negative b squared. Did you say negative 1?
No 1.
No, it's negative 1. I squared is negative 1. So I have negative b squared times negative 1 is what?
B squared. 1 B squared.
How about positive b squared? Yes. Negative b squared times negative 1 would be a positive b squared. So you have been told in the past that you can factor the difference of squares. That would be the difference of squares, yes? So it would be x minus 3 and x plus 3. Yes? But you guys know that you can factor the difference of the sum of squares as well? All you have to add in there is a what? An I. Because what the both squares, right? So you have x minus 3i and x plus 3i. Because that I and that I is going to be a negative 1 and turn it back to a positive.
Yeah.
So it is possible to factor the sum of squares. It's not something that you guys are probably going to just see and go, ooh, I can do this. But I'm going to tell you it does work. Because when I multiply this out, I have x squared minus 3, oh, that would be 9, minus 9i plus 9i minus 3i squared. So what is this I squared? Negative 1. That should be a 9. I don't want to multiply my 3's evidently today. And a negative 1 times a negative is a positive. Okay? So you can factor some of squares as well. They only just tell you the difference. Because the difference, I have real numbers. These are real numbers, yes?
Yeah.
Are these going to be real zeros? No, because they're going to have i's in them. Like if I set those equal to 0, it would be x equals plus or minus 3i, wouldn't it?
Yeah.
Which is an imaginary number. So that's not on the x-axis, but it is a 0. It's just not a real 0. So complex conjugates and conjugates are the same thing. If you only remember one word, it needs to be conjugate. In trig, I'll get people going, I'll say, what do we have to multiply by? And they're like, the complex conjugate. No, it's not the complex conjugate. Just conjugate. Because complex means it has what in it? An I. So if you remember one thing, it should be just conjugate. Okay? What is the point of a conjugate? What is the point of the conjugate of here? What happens to my middle term?
Find the difference of squares.
Right, but the middle
Get
two
rid of the
terms
middle
zeroed out, right? Okay, what was the point of the conjugate down here? Middle two terms zeroed out, but it also made it real numbers, didn't it? Okay, so that's the point of a complex conjugate is not only to get rid of that middle two terms, but it's also to make it real numbers because we want real numbers in our world. We want to work with real numbers. You like imaginary numbers. Okay, so multiply each complex number by its conjugate. So they don't have parentheses around them, but are there really parentheses around them?
Yeah.
Yes. So I have 1 plus I. What is its conjugate?
1
minus I.
1 minus I. And when I multiply that out, do I have to convince you that there's no middle term anymore? Can you go with me there? No? Okay. So 1 minus I plus I minus I squared. So 0, yes?
No.
Minus I squared is what?
Oh.
It's negative times a negative 1. So it's 2.
Wait, where'd you get 2? Because she just did.
Oh, really?
So why is it plus a positive 1? I thought.
Because it's minus, what is I squared?
Negative 1.
So it's negative, negative 1.
Oh, why is it negative?
Because the problem says negative.
Oh, okay. Oh, got you.
Okay, so 4 minus 3i, what is its conjugate?
4 plus 3.
4 plus 3.
Multiply it out.
You just wait. I'll get it.
I know,
Yes,
that's why I
give me a
said you do it.
I might not do it.
Okay, I beg to differ. I might not.
So say I'm taking 4 times 3i, can I multiply 4 and 3?
Mhm.
So it's 12i?
Yeah.
Why can you multiply 4 and 3?
Okay. Because it's your most multiplication. You can't add them, but you can multiply them. Just like if it was a variable. You can't add them, but you can multiply them. Think of it as an x, guys. It's just a variable at this point when we're doing the math. But is it really a variable? No.
Can't you still solve it?
Yes.
Okay.
I didn't know if everybody was there. So you
Okay,
should
I
have
got
multiplied
that.
it and simplified it to that. Okay? So this negative, this is what?
Negative 1.
So this is really,
Positive.
so it's 20.
5.
Yeah! I'm so proud of myself. Good job. Sorry, so proud. I just keep my eyes over. So, and I to second power
That's okay,
will
it's
always,
just Riley.
is always negative 1.
Mhm.
I get 5.
Okay, so I hate these square roots. I apologize. That's how the computer did them. So I have the square root of negative 15, and then that's plus 0i, yes? So we can do it just so you can see it, but I'm not going to do it again if I don't have to. So what's its conjugate?
Negative 15.
Negative.
Square root minus 0i.
Yep,
So you only change the last one?
the middle sign. That's it. So the 0 is not going to do anything, right?
Yeah.
So I have the square root of 15i squared. Or, sorry, not I. Square root of 15, negative 15 squared. Yes?
Yes.
When you square a square root, does anybody know the rational exponent for the square root?
We look like we do.
No, sometimes some of the things you guys know, the exponent for this is a half. We've talked about that. I know we have. Because this is the root, and this is the power.
Trying to put it into the graphing calculator.
Yeah. So this is the root, this is the power. This is why this works. I'm just showing you why it works. So this is negative 15 to the 1/2 squared. When I take a power to a power, what do I do to them?
Cancel.
You add them.
Multiply them. So half of 2 is what?
1.
So, whoa.
This is
Negative
why
15.
when you square a square root, you get what's inside. I wanted to show you. When you square a square root, you get what's inside, but that is why.
So your answer is just negative 15.
Mhm.
So now do we do this one on our own probably?
Oh, you can.
Yeah.
This one's going to be a quantity, though, right?
So, never
What the
mind.
heck is a quantity?
What's my conjugate?
1 minus
1 minus square root of 8. So try it. Believe in yourselves. Remember, you can only combine things that are like terms, right?
I don't even know how you got negative 15 on the middle. Like, where did you get that 2 at?
Because I have squared, I have this times this, which would be the square root of negative 15 squared, which is
Then you would
negative
change
15.
that to a half, right?
Yeah, because I was showing you mathematically why when you square a square root, you get what's inside.
Oh, okay.
I was showing you why. That's why it works.
What happens when I take the square root of 8 times the square root of 8?
What do you think you get? 8.
Square root of 60.
No, you get the square root of 64, which
Because
is
that's
what?
8 squared. Square root of 8 squared, so it's
8.
stop.
Oh
my god.
I'm pretty sure.
I
that-
literally need to stop.
Okay,
Well, I actually think it's
so you should have gotten 1 minus 8.
Ooh.
I got 1.
Ha.
Let's go.
the square root? Oh, wait.
How did you get plus?
Because I had 1 minus square root of 8 plus square root of 8 plus 8.
It should be
But you, it should
Oh,
be
it
minus.
should be a minus because that's a negative
Can
square
you do that whole thing out for me? I'm sorry.
So 1 minus the square root of 8 plus the square root of 8 minus the square root of 8 squared.
Stupid.
I like it. Or you are.
So it's negative.
Haley?
Let's go, I got it
In that conjugate, do I ever need to worry about the middle two terms?
Sure.
No.
No.
If you make the correct conjugate, I will have people, I'll give them something like this, right here, and they tell me the conjugate is this. What is wrong with that? They changed the y. So it's not going to be what they think it's going to be. So make sure you're only changing the middle term.
Got it.
Okay, use complex conjugates to write the equation in standard form. Okay, we cannot have a complex number on the bottom in the denominator. Let me use the right word. We cannot. If you leave your answer like that, it's not simplified. That's what this whole section's about. In any other test, it will miss you only a half a point. In this test, it will miss you 1.5 points. Because this is what this is about. Okay? So, I have to get it to a real number. So what do I multiply an imaginary number by to get it to a real number?
4.
It's
It's conjugate.
conjugate. We just went through this. The whole point of a conjugate is to get it to be a real number, yes?
Yeah.
Can I multiply any fraction I want by anything I want? Yes, as long as I do it to the numerator and the denominator, both. Okay, so I have 1 minus I. I don't care about the I in the numerator. Don't care about it at all. 1 plus
1
I.
plus
So I'm going to multiply 1 plus I up here
I. I already
Wait, why is it 1 plus I?
because it's the conjugate. Okay? So in the numerator, I'm just going to do what?
Crossing them out. Oh, wait.
Distribute.
Distribute.
So I have 3I plus I squared.
Wait, would it be 3I squared?
Yes.
We're gonna ruin my
Okay. In the denominator, I'm not going to do the middle two terms, guys. I'm not. Because what are they going to do every time?
Cancel
They're
out.
going to zero out. We're not going to use the word
So
cancel.
1 plus I.
If you are not convinced of that, you need to keep doing it until you are convinced of it. Understood?
1 plus I squared.
Okay. So it should be 1 minus I squared in the denominator. Why is it minus?
I have no clue.
You have a negative times a positive. So it is a negative.
Got it. Oh,
Okay. So now, this I squared makes this 3 a what? Negative. And I have to write it in standard form. So the negative 3 comes out front.
Oh, switch the sign.
Okay. This I squared is what?
Negative, so positive I.
So I have negative and negative 1. So I have what? 2. Now, I'm still not in standard form because the imaginary number is not completely separated. So I just separate this fraction. It's going to be 3 over 2 plus 3 over 2 I. Yes, question?
When you're foiling and because like the middle terms will always cancel out, so to make it easier, could you just take like with 1 minus I and then 1 plus I, could you just say 1 times 1 and then negative I times I, and then that would
Okay.
be like your.
This is my thing with that. I don't have a problem with that, but there are people in this room that will still tell me that this is x squared plus 49, which it is not.
Oh, well.
That is my problem with just doing what you said.
Okay.
Because why is this not x squared plus 49?
Because it's not a middle term.
There's not, I need to FOIL, yes?
Yeah.
So there should be 14x.
So it should be x squared plus 14x plus 49. Okay? That is my problem with just saying do that. Because that's all that's going to end up there, yes? But we need to correct some mistakes that we have. So if you're a person that does this, don't be going there. Because you're going to do it everywhere.
Wait, James, what?
I have people doing this problem incorrectly still. They're not foiling it out.
Oh, I know.
And so that's why I don't do shortcuts, because shortcuts make misconnections in your brain. Yes.
Did you
There is
just
no connection.
so when you go from start like the second 3i plus 3i squared and 3, well I is -1, so 3 -1 -3. Did you just switch the numbers around?
Yes, because I have to put it in standard form. Standard form, the real number has to be first. Okay, now this is the last thing. I just took this fraction and separated, yes? Because when we add fractions and have common denominators just over the denominator, I just went backwards. You are not done until your problem looks like this.
Awesome.
That I has to be standalone all by itself.
Okay, someone needs to give me this.
Okay. So, write the quotient in standard form. What is wrong with this problem?
There's eyes.
There's there can be i's. Where is the problem where the I is? In the denominator. Okay?
So we got a 1 plus 2i.
And if I multiply in the denominator, I have to multiply in the
The
numerator. And you better put parentheses because you have to FOIL it out.
Okay.
So do it.
Oh boy.
Yeah, can you show us this?
We FOIL out the top and the bottom, yeah?
Mhm.
Okay. You're gonna need to give me a few minutes for this.
You should have already started.
It's actually
I'm really slow. Okay, I think I did it right,
Okay.
but I only got
Keep
the
going.
Okay.
You have to finish it. If you FOIL it out, just keep going, simplifying. I'll put the answer for the FOIL in a second.
Can I play with these Legos?
No?
Wait, is one just I just positive or -1?
No, I is I.
I swear, I do not get that part.
I squared is -1. I is just I.
got the first number right. I didn't put something in the middle.
Yeah, I didn't put the 5i.
You should have.
Where's that come
How
from?
did you get it?
7
and
7 times 1, -7 times 1, and 6 times 2.
Oh.
You have to FOIL, right?
Little oops.
Well, wait, what? So you can only zero the middle term.
Hey, you didn't put it
And it gets where it
I know,
comes.
but
Well,
it's so
you
good
guys
to
don't do it. FOIL the way you're supposed to. Don't be taking shortcuts because you're not making them the right. Like I just said, shortcuts make misconnections and get wrong
Honey,
answers.
I thought the
said that
middle
there's
terms
no
canceled
middle.
out.
Oh, not if it's not a conjugate.
Yeah,
The
I got
numerator is
not
not.
for the top. What the?
The numerator is not a conjugate of each other. Correct? The
Yeah.
only time the middle terms are going to zero out is when these are conjugates.
That's not what I got.
So you should not be shortcutting yourself. You should multiply them all out.
Is that the end answer?
No.
So now would you like to take, well, so -14i squared would just change to 14, right?
Go positive
So it'd be
14.
20 plus 5i. I have that. And then the 4i squared would change to 4.
Yeah, you're on
Okay,
the
so
top.
5.
Oh my god, I had that.
Now we love God.
God's lost. Yeah, we love him. Well,
Oh, well, I didn't get that.
Wait.
yeah, plus I.
I thought I squared turned into
Yeah,
Oh, I had it. I
so
just
does.
didn't combine.
Oh,
Turns
then
into
you
negative 1.
Oh, you divide by
This
5.
was negative 14
Yeah, I guess.
I squared. This is negative 1, so that becomes a positive. This was negative 4 I squared. This is a negative 1, so that becomes a positive.
Oh,
I got
thought
it.
was already-
14 plus
Dude,
2.
that's what I got.
Yes.
So did you divide
Oh.
each
Okay, we need to stop. Yes, Sadie.
You do, so when you had 20 plus 5i over 5, did you divide each number on
You
top
have
and
to
bottom?
divide each number by 5, yes. If you're dividing a polynomial, each number gets divided. If you can't, then you can't do it. if it was 14 plus 5i over 5. It's a what if. Don't ask me where I got it. Okay, does 5 go into 14?
No.
No. So it's 14 fifths plus I.
Okay.
Okay? Okay, we have to add. We have fractions. When we add fractions, we have to have what?
Common denominator.
Common denominators, yes?
Yeah.
And we
We don't. Now, there's two things we could do. I personally like to look at the left as one problem and get a real denominator. How would I get a real denominator over here? Multiply by the what? Conjugate. Because then I would have a real number to work with, yes? And then I look at the right and I get a real number. So how would I get a real number? Multiplied by the conjugate. Then after I've simplified both of them, I worry about getting common denominators. Everybody understand what I'm saying?
Yes.
Some people like just to say, well, I'm just going to multiply this by this and this by this. Because if I had 7 fourths plus 9 fifths, how would you get your, you'd multiply 4 by 5 and 5 by 4, right? So some people,
I think
well, that's the only way you can add those two. Okay, so we can do these, we can approach these problems two different ways, okay? If we multiply the left by the right and the right by the left denominators, you probably are going to have to do conjugates at some point, okay? I just prefer to do them initially so I have real numbers to worry about common denominators with. So that is how I'm going to show you to do it. So we're going to look at the left. What is it?
minus 2 minus I
Okay,
on both
so
sides.
not on both sides.
Or
Just-
top and bottom is what I mean.
Yes. Okay. Now I'm going to look at the right. What is my conjugate there? 2 plus I. Top and the bottom. My hand's bothering it. Okay. So do the left is a problem and the right is a problem. So do it.
Hey. Foil. You're going really fast up there.
Don't look at mine then.
Okay.
That should be an I. Then my dot didn't show up.
Hey, shut up.
Gosh, imagine doing it right. Ooh. What if you did it wrong and you just think that you did it right?
Okay, but I did one thing wrong, but that's cool.
What one thing did you do wrong?
I didn't take 2 times 2 for it to get 4 minus 2i. I had 2 minus 2i, but that's okay, because
You can fix that.
do we have a common denominator now?
These two happen to have a common denominator because if you were thinking, look up the top. They are what of each other?
Conjugate.
Conjugates of each other. I just didn't point that out. Okay? These do happen to have a common denominator, so now all you have to do is combine like terms in your numerator, right? Yes.
I have a slim problem. I got 4 plus 2i. So how would have I got that?
And where? The left numerator?
I got 4i plus 2 instead of.
Yeah, I got 4i plus 2 too.
I also did. It's because it's I squared and the negative makes a positive.
Oh, I forgot to square. Yes?
Thanks.
I forgot to square?
Yeah.
Wait, but wouldn't 2i times 2 be 4i?
It'd be
Yeah,
four.
Yeah, I got 4i plus.
At the very
Yeah,
top.
I don't know what I was
Okay,
doing.
that's what I had, and then you made me confusion.
No, you ask and I fix.
I did it right.
Okay, so now hopefully, no, finish it out right.
Oh.
Finish it.
Wait, you're gonna need to give me like 3 minutes to do this.
Yeah.
Not 3 minutes.
Yes, I'm serious. I work like a snake.
Okay, the 12 or like the I has to go last, correct?
If I got this right, you owe me a cookie. And you owe me a cookie.
And you don't owe me a cookie. I put it all together.
But you owe me a
12
cookie.
plus
so.
9, I all over 5.
Okay, but that's not wrong, but you're not done.
Oh, not done.
That's the in between stuff.
That's the in-between step. You didn't finish.
Look, there's different clouds over there.
You just had to
Hey,
combine like terms.
How come the I?
Like, you know,
How come the I goes to the 9 over 5
I
and
got
not to the 12 over 5?
Because the eyes with the 9 and
Oh,
not the
okay.
12.
Oh, so now we're just
I
adding.
don't even see.
Just add the name card on the top.
Oh.
With the 4i. Should. So with the 4i plus 2 plus. You take it 4i plus 2 and then add that to 10 plus 5i.
Because you have common denominators.
Yes, you just combine.
Now, that doesn't always happen.
When we get happy and she's
Like here. Okay,
Who's this?
Wait,
So-
wait, on the 4i plus 5i, wouldn't that be 9i squared?
no, you're adding. You don't, exponents stay the same when you add.
Okay, so then what do you do now? Like, oh my gosh.
You just write it like a complex number. Okay, so when you approach one of these problems, the first thing I would do is make sure, like, look at their denominators. If they're conjugates, great, right? Okay, if they're not, which most of the time they're not,
Oh, great.
Oh shoot.
Oh, looks like we can have it all math.
You
That's
can
what I
drop
meant.
the pen and like stop on it.
no, it's because whatever they're doing upstairs.
Whole painting.
Stop there.
They're painting up there.
No. Seriously. Okay.
No, they really are.
Okay,
Those are the
shh.
same.